Welcome back to 3 Inquisitive Kids. In this video, we will be looking at how to solve systems of equations using the addition and subtraction of equations. Eliminating variables using the addition and subtraction of whole expressions. That is a topic we have actually covered, I believe, in the previous grade level, where we talked about how to add and subtract whole expressions. Now we're going to combine it with adding and subtracting equations. This is part 2 to our second lesson, simplifying systems of equations. The two learning goals for today is to master adding subtracting expressions on either sides of equations and to solve systems of linear equations in two variables using the addition and subtraction of whole equations. So let's start with an observe and think. We know that it costs $23 to buy 3 apple juices and 2 orange juices. It costs $33 to buy 5 apple juices and 2 orange juices. So how much would 1 apple juice cost, and how much would 1 orange juice cost? Well, here's our solution. First, just like the solution to any system of equations problem, we set the variable. Let each apple juice cost X dollars and let each orange juice cost Y dollars. Therefore, we can obtain the two equations 3x plus 2y is equal to 23 and 5x plus 2y is equal to 33. So how can you solve this system of equations? In the last video, we learned all about the substitution method. Can you use the substitution method right now? You definitely could, but there is another way. First, we can convert the equation 1 into x is equal to 23 minus 2y divided by 3. That we can rename this as equation number 3. Substitute equation number 3 into equation number 2, and we have 5 times equation number 3 plus 2y is equal to 33. Our solution is y is equal to 4. Substitute y is equal to 4 into equation number 3, and we get that x is equal to 5. So therefore, the solution is x is equal to 5, y is equal to 4. This is, of course, the substitution method. But is there any other way? Solving systems of equations using the addition and subtraction of equations. Explore. How can you simplify the following system of equations? Here we see two equations, equation 1 and equation 2. And we have two variables, x and y. This is common solution. We can first convert equation number 2, into x is equal to 5y minus 11 over 2. Substitute that into equation number 1, and then we can eliminate x. So this is using the substitution method from last time. Here's Karen's method. Convert equation number 2. So sorry, there should be a bracket right here. It's actually there where you might not be able to see it. Always remember to write the bracket sign. Convert equation number 2 into 5y is equal to 2x plus 11. And then substitute that into equation number 1. So what she's saying here is you don't have to just isolate the one variable. You can look for a term. And that term here would be 5y is equal to 2x plus 11. You can also use that. This is still another type of substitution. So this is still the substitution method. But is there any other way? So here's Kaylee. She's thinking that 5y, again, the brackets should be red. She's thinking again, 5y and negative 5y are opposite numbers. So why did she think that? Why is that important? So using her way of thinking, can you eliminate a variable? Analyze. We can first, another important part of why we have to call this equation 1 and this equation number 2 is we can organize our thinking. When we add these two equations together, you can write equation 1 plus equation number 2. So this right here is 3x plus y. This here, underlined in blue, is 2x minus 5y. So we're adding these together. So you can think of both of these as whole expressions, and we're adding them. On the right side, we have 21 plus negative 11, and that's highlighted in black. So basically what we're doing is adding the left side of both equations and adding the right side of both equations. Therefore, get x is equal to 2. So she's saying that 5y and negative 5y are opposite numbers. In this way, this is important. This is important because what we're doing here is essentially by adding them, we can cancel out plus 5y and negative 5y, resulting in x is equal to 2. So finding the solution to this, we can first add equations 1 and 2. Again, this is equation number 1, this is equation number 2. Add these two equations and we get 5x is equal to 10. Therefore, x is equal to 2. After that, we can substitute x is equal to 2 back into equation number 1, so y is equal to 3. Therefore, the solution to the system of equations is x is equal to 2, y is equal to 3. Let's do some practice with what we've just learned. Find the solution to this following system of equations. Here. So the solution is we can add both equation 1 and 2. So therefore x is equal to 0.6. Substitute that into equation 1. We get y is equal to 0.1. Therefore the solution is x is equal to 0.6, y is equal to 0.1. So what's our conclusion that we can take away from this? When the same type of variable has coefficients that are opposite, right, because say here, plus 10y, negative 10y are opposites, previous plus 5y, negative 5y, those are opposites too. So when the coefficients of the same type of variable are opposite, you should what the two equations that include these two variables. You should add them to eliminate that variable. Remember, whenever you add opposite numbers together, you get 0. Okay, pause the video to try to solve example number 2 on your own. So in this case, how would you have used the addition and subtraction of whole expressions or whole equations? Well, we don't see any opposite numbers here, but we do see the same sort of term. The coefficients of the variable x in equations 1 and 2 are equal. See, there's 2x here and 2x here. Therefore, x can be eliminated by subtracting these two equations. So yes, if you can add equations, you can also subtract them. Basically, what we're doing is we're subtracting the left sides of both equations, and then we're subtracting the right side of both equations. Remember, since right now we're subtracting equation 1 from equation 2, you're always going to be subtracting the left or right side of equation 1 from equation number 2. So do not mess up the order. But of course, if you were subtracting equation 2 from equation 1, you would switch up that order. Therefore, y is equal to negative 1. Substitute that into equation number 1, and we get x is equal to 1. Therefore, the solution is x is equal to 1, y is equal to negative 1. Let's do some practice. Pause the video and see if you can use the addition or subtraction of whole expressions to help you solve. Solve the following system of equations. Okay, so here's the solution. If we subtract 1 from 2, we have x is equal to 5. Substitute that into equation number 1, y is equal to 4. Therefore, the solution to the system of equations would be x is equal to 5, y is equal to 4. Compared with the previous substitution method, this one is much more simpler. Of course, it depends on which one you like better or which one you're better at or feel more comfortable with. But personally, I like this better because you can really, because the substitution method makes you first so when you're using the substitution method, you have to first make the equations more complicated and then you solve them and eliminate a variable. By using addition and subtraction of whole equations, you can eliminate a variable right away. Conclusion. When the coefficients of a variable in two equations is what do you have to do to the two variables to eliminate the two, this should be equations to eliminate the variable. So if the coefficients are equal, like 2x, or 8y, you subtract the two equations in order to eliminate the variable. So another conclusion. When the coefficients of a variable that exists in both equations in the system of equations are opposite or equal to each other, the two sides of the equation can be added if the coefficients are opposite, or subtracted if the coefficients are equal, to eliminate the variable. From this, you can obtain a linear equation in one variable and then solve. Again, this is still going back to that idea of trying to eliminate as much variables as possible, because we can only directly solve a linear equation in one variable. So if it's multivariable, you're trying to eliminate variables as much as possible. The method of solving systems of linear equations like the above is called the method of addition and subtraction of equations. Example 3. Use addition and subtraction of equations to solve. Pause the video and see if you can use what we've just learned to determine whether to use addition or subtraction to solve. Here's the solution. First, multiply equation 1 by 3. So by doing this, you're multiplying 3 on both sides to every single term. And multiply equation number 2, so this we're going to call equation number 3. Multiply equation number 2 by 2, and you get 6x plus 8y is equal to 34. This is equation number 4. Subtract 4 from 3, and we get y is equal to 2. Substitute x is equal to 3. Therefore, the solution is x is equal to 3, y is equal to 2. There's one extra step in this solution that differed from the previous problems. Did you catch that? It was the first two steps, where we multiplied each of the equations to get two more equations that we can use subtraction of equations with. So first we had to multiply this on both sides by 3, and multiplied the second equation on both sides by 2. Also, we can get 6x and 6x. We're trying to aim for coefficients that are either equivalent or opposite. So sometimes if the equation given is not exactly like that, you can multiply or divide on both sides to make it have the same or opposite coefficients. So solve. First, again, we can multiply equation 2 on both sides by 4. So that would be equation number 3. Add equation number 1 and 3 together, 7x is equal to 35, therefore x is equal to 5. Substitute into equation number 2, and y is equal to 1. So therefore, the solution is x is equal to y is equal to 5, and y is equal to 1. Method conclusion. When the coefficient of the same variable is blank, use the properties of the equation to make the coefficient of the variable blank. So when the coefficient of the same variable is not equal nor opposite, you can multiply, divide those equations, but make sure you're doing it correctly, on both sides to make it equal or opposite. So for example, in that case, we were trying to find the least common multiple of the coefficients. Here are the general steps for solving a system of equations using addition and subtraction. So here are the features. The coefficients of the same variable are same or opposite to each other and shares the same absolute value. So this is something that should start hinting you towards using addition and subtraction of equations to solve your system of equations. Because if the coefficients either are the same or are opposite, so they have the same absolute value. So the goal is to eliminate variables. So we're trying to turn it from multiple variables into one variable. The solution is to add/subtract, minimize the number of variables, sort of like the previous one. Solve, find the value of multiple variables separately or one by one. Answer, write the solution to the original system of equations in a proper manner. So this means it's grouped together using a set of brackets. So writing neatly and organized, and if it's part of a word problem, always make sure to actually include the units, or better yet, put it in a full sentence. Example 4. Given that, and we have a system of equations, what is the sum of A and B? Well, here's our analysis. If we're going to try to find the sum of A and B, we first have to find the values of A and B, right? So what we can do is first add. So there's two different ways to do this. This is method 1. Directly solve. We can use substitution method. We can use addition and subtraction of whole expressions to find A plus B, right? Another way is if you just look at both of these equations as a whole, and you look at each of the coefficients of the variables, you see that, for example, 2b and 2b added together, it's 4b. A and 3a added together, that's 4a. So being flexible like this with your thinking and your observation skills are very crucial when it comes to solving systems of equations or even just math problems in general. So why don't you first just add equation number 1 and 2? And then you have 4a plus 4b is equal to 12. Since both sides is divisible by 4, do that, and you'll have a plus b is equal to 3. This way you don't even have to find the individual values of a and b. So therefore, a plus b is equal to 3. So here's our method conclusion. The key to solving the problem is to observe the coefficient relationship of the same variables of the two equations. After that, use a method of addition and subtraction to solve the problem. Here's yet another example. Solve this system of equations. Think about the coefficients right now. Pause the video to solve. So here what you've noticed is that x and y may not be the same variable, but can you think of them as a group? You can substitute x plus y is equal to a, and x minus y is equal to b, and then replace this as a, b, a, b. Think with that mindset, because no matter what, it's still the coefficient. So the same rules will still apply. Add these two equations together and you get 4 times the sum of x and y, and that's equal to 36. Divide 4 from both sides, we get equation 3, x plus y is equal to 9. So since x plus 9, okay, so now we're going to subtract equation 2 from equation 1. And you get this equation right here. 6 times the difference of x and y is equal to 24. Therefore, x minus y is equal to 4. That's our fourth equation. Simplify the system using equations 3 and 4. And we know that x plus y is equal to 9, x minus y is equal to 4. Solved, x is equal to 6.5, y is equal to 2.5. There's also another method too. We could simplify it into 5x minus y is equal to 30. Negative x plus 5y is equal to 6. Okay, now let's look at this word problem together. 2 large trucks and 5 small trucks can transport 36 tons of garbage in 2 hours. 3 large trucks and 2 small trucks can transport 80 tons of garbage in 5 hours. How many tons of garbage can each one of the large truck and one small truck can transport? So let's look at the solution. Suppose a large truck and a small truck can each carry X tons and Y tons at one time, respectively. According to the question, the system of equations that can be obtained is, and we have it written out right here. Simplify, and we have 4x plus 10y is equal to 36. That's equation number 1. Equation 2 consists of 15x plus 10y is equal to 80. Subtract 1 from 2, we get x is equal to 4. Substitute that into equation number 1 to get y is equal to 2. Therefore, our solution is x is equal to 4, y is equal to 2. But remember, since this is a word problem, you have to answer in a full sentence. An acceptable answer would be something like, one large truck can transport 4 tons of garbage, and one small truck can transport 2 tons of garbage. Something like that. That's what you should be answering your word problems with. Class summary. Solving systems of equations. We learned all about how to understand the concepts of eliminating variables. That's something we've been looking at ever since the last lesson, where we talked about the substitution method. We also covered the general steps of adding and subtracting linear equations into variables. Our first skill is to master adding and subtracting expressions on either sides of equations, and our second skill was to solve systems of linear equations in two variables using addition and subtraction of whole equations. Thank you so much for watching through Inquisitive Kids. If you found this video helpful, please feel free to others as well. Subscribe for other videos coming up. Thank you so much again, and see you in the next lesson.